All right, today we're going to dive into a really fascinating piece of tech, a robotic arm that's been engineered to work completely on its own. We're talking no cloud, no Wi-Fi, no strings attached. This is the story of the sovereign helping hand.
And that quote really just nails it, doesn't it? For all the incredible things we've accomplished in the digital world, actually getting stuff done in the messy physical world has always been that final tricky step. Well, this technology is designed to take that leap.
Okay, so to really get why this robot is such a big deal, we first have to understand the problem it's trying to solve. Let's take a look at the fundamental challenge facing most robots out there today.
I love this slide because it lays out the contrast so clearly. The digital world, the world of code, it's clean, it's predictable, everything makes sense. But the physical world? Oh man, it's messy, it's unpredictable, and a lot of the time it's completely off-grid. You can't just assume you'll have a perfect internet connection out there.
And that brings us to the core issue. Most modern robots are really just glorified puppets for the cloud. They have to have Wi-Fi, they're totally dependent on some company's servers, and if that connection goes down, well, they pretty much become very expensive paperweights. They're basically useless in the exact places we often need them the most.
So, what's the fix? Well, let's meet the hero of our story, a piece of hardware designed from the ground up to tackle this exact problem.
So let's break this down. It's a 6-axis industrial arm, which just means it can move around with a ton of freedom, almost like a human arm. But the key phrases here are IP67 rated. That's a fancy way of saying it's super tough against dust and water. And off-grid. It's truly built to go to work where other robots just can't.
And you can really see that toughness when you look at the specs. I mean, we're talking about an aerospace-grade aluminum body. It runs on direct DC power, from a solar panel or a battery, so there are no risky internal batteries to worry about. And you can swap out the hand for a gripper, tweezers, a camera, whatever you need. This thing is a serious workhorse.
And hey, just for a little context, the base model is priced at just under $3,000. So this isn't some far-off, futuristic concept. It's a real tool that's being built for deployment right now.
So how in the world do you make a robot truly independent? This is where it gets really interesting. The process is called a brainwashing, and it's a pretty radical, physical transformation.
Check out this process. It's 3 steps. First, they start with a standard robot right off the factory line. Then comes the wild part, the brainwashing. Technicians literally gut the robot and rip out all the standard Wi-Fi and cloud controller boards. Finally, they retrofit it. They solder a special DeReticular adapter directly onto the motors. This adapter uses something called RS-485, which is a super reliable, hardwired way for things to talk to each other. It's a complete physical cutoff from the cloud.
And the before and after is just night and day. It goes from being this dependent, cloud-tethered device to a sovereign tool that is, and I just love this phrase, deaf and blind to the cloud. All the control is 100% local, running over that physical wire. That right there is the whole game changer.
Okay, so we've got a tough, independent robot. That's cool, but what does it actually do? Let's check out 3 real-world missions that this arm is designed for.
First up, we've got a mission that could totally change how we think about farming. It's called the AgBot Harvester.
So, imagine a little rover driving through a field. An AI on board spots a perfectly ripe piece of fruit. The arm then reaches out with incredible precision, gently grips it, snips the stem, and drops it into a basket. Now here's the really cool part. Every single time it does that, it creates a secure, digital record called a proof of harvest. Why does that matter? It means you can prove, without a doubt, exactly when and where every single piece of produce was picked. That's huge for things like supply chain transparency. It's automation and verification all in one.
All right, next up, we're moving from the farm to the server room with a mission they're calling the Deep Admin Reboot.
This is just brilliant. We've all been there, right? The computer freezes up so bad that nothing works, and you just have to hold down the power button. Now, what if that server is hundreds of miles away in a data center? Well, this arm can literally reach out and physically push the button. It's a physical solution for a digital problem when everything else has failed. And for our third mission, we're going even more remote, to a place where staying connected is absolutely everything. Meet the antenna aligner. So picture this. A big storm rolls through and knocks a satellite dish out of alignment at some remote outpost. Instead of having to send a crew out there to fix it, the system just notices the signal is weak. The arm then automatically gets to work, fine-tuning the dish's position until the signal is perfect again, and then locks it back down.
That's totally autonomous self-maintenance.
Now, I know what you might be thinking. Giving a machine this much physical power and freedom, that raises a pretty big question. How do you make sure it's safe? How can you actually trust it? Well, let's look at the safeguards that are built right in.
They really thought this through and tackled 3 huge risks. First, what if it crashes into something? There are strict hardware limits on its power, so if it hits an obstacle, it immediately stops and goes into a safe node. Okay, what about power surges frying the electronics? The powerful motors have their own isolated power supply, totally separate from the delicate computer boards. And maybe most important, what stops it from being hacked? Well, any high-risk action requires an encrypted OK from a human operator or even a physical key tap. It's a really smart, layered approach to safety.
So when you put it all together, that's what this is all about. It's a tool that is finally, truly bridging that gap. The gap between our clean, logical commands and the messy, unpredictable, real work that needs to get done in the physical world, no internet required.
And this really just leaves us with a fascinating question to chew on. As our machines get smarter and more independent, what does control really even look like? Is it having a constant internet connection to them, or is it about building systems that you can trust from the ground up, with safety baked right in? It's a question we're definitely going to be dealing with a lot more in the years ahead.